Okay, so the plan here is to try this problem here for 30 minutes, try and come up with a brute force plan and optimal plan, time and space complexity, and try and implement. So 3 things. And I'm going to set a 30-minute timer, and then once I'm done, if I don't complete it, then I'll go look at the solution after 30 minutes. So that's the plan. And how do you find this problem? Let's see, leetcode 17. Does that work? Okay, so if you just search leetcode 17, it's the first link. And I also left a link in the video description, so you should be able to find it there. Okay, so alacrity. Okay. Let's see here. Leetcode. Okay, so let's remove these things. Okay, this is all junk. Okay, so let's try and come up with a plan for this one. Let's see if we can get this working. So yesterday's having trouble with these type hints, so let's see if we can get that working today. Okay. Nope. Alright, we're just removing the type hints for now, I guess. Eventually we'll get those to work, but for now, we're going to remove it. Interesting. What am I missing here? Anyone in the chat know what I'm missing? Okay. No one's here yet. That's okay. Alright. So this takes some argument. Oh, it takes digits. So 1. That's the problem, I think. Oh, okay. Oh. Wait, so is this going to work then? str list of ints. One, two, three. Invalid syntax. Not sure why that's invalid. Maybe I have to do init class Python. There's a special function that you have to do. It's like init or something. There it is, this one. Maybe this is what I'm missing. It's not clear. Huh. Python class type hints. Wonder what I'm doing wrong here. Not going to spend too long on this. Okay. Okay, so here's an example with types. What are we missing? Nope. Expected an indented block. Python type hints. Syntax error. Oh, Python. Which Python am I using? 3.9. Okay, we're just removing type hints. We're getting to business here. That's okay. Okay, so we're going to use Python. No, Python 3. That's okay. We'll keep, here's what we'll do. We'll go like this. We'll keep our type hints right here. So this is going to be a string. And we're going to return a list of strings. Okay, cool. I think this should work. Let's see. Okay, cool. That's working. All right. So let's read the problem. Given a string containing digits from 2 to 9, inclusive, return all possible letter combinations that the number could represent. Oh, cool. So if you've seen those ads, it's like 1-800 call now. Those letters, like 1-800 call now. 1-800 call now. So C is 2, A is 2, L is 5, N is 6, O is 6, W is 9. So this equals 1-800 2 2 5 5 now 6 6 6 9. So the question is, like, there's one mapping of letters to numbers, but there's many mappings from numbers to letters. For example, 2 can be A, B, or C. 2 can be A, B, or C. 5, A, B, or C. C, A, B, or C. Okay, so I think I understand what's going on. I understand the input. What is the output? Given a string containing digits, return all possible letter combinations that the number could represent. Oh, okay, so like, if we get this string, 22556699, call now would be one possibility. Okay. Return the answer in any order. Okay, we're returning a list of strings of all of the letter combinations. Okay, got it. A mapping of digit to letter, just like on the telephone numbers, is given below. Note that 1 does not map to any letters. Okay, so we're going to have a map digit letter. This is going to be a map. We'll fill this out later, but it's going to be map of digit to letters, like a list of letters or something. Okay. Okay, no one's here. That's okay. All right. Note that 1 does not map to any letters. Got it. Okay, so now, my strategy is to like walk through the examples and see if I can develop some intuition, then turn that intuition into code. Okay, so let's try this. All right, so let's see. Okay, so how do we go from 2, 3 to all of these? So we have this map. 2 can be A, B, or C. Three can be D, E, F. Okay. So how do we go from 2, 3 to all of these? Okay, so is it combinations? So my question is, AD is in the output, is DA? Is DA? Okay, there's no DA. There is AD, but there's no DA. So we're doing combinations, not permutations. Okay, got it. Okay, so I have an idea for what we're doing here, for how we get from input to output. Okay, so we're going to have 2 pointers, I, J. So for every pair, we're going to do 2 for loops, and for every pair that we land on, we're going to add it to our output. So let's start here. We're going to add AD. Let's see if this works. AD, and let's go like this, because it's easier for me to read. Okay, AD, and then we're going to increment this guy, so AE, increment, now AF, okay, 8 up, this comes back here, this increments here. Now we're going to do BD, so let's see if this is going to work or not. BD, okay, there's BD, cool. AF, AE, AD, cool. We're looking good so far. And now, are we going to do BD? Oh, we've already done BD. When did we do BD? Oh, BD, we just did it, okay. Increment BE, okay, 10 up. Now BF, up, increment C, okay, CD, 11 down, CD, now increment J, CE. So I'm already getting a feel, like we can, I think I have a brute force solution. We're going to do a nested for loop. Let's see. So CD, CE, CD, CE, and what else? Let's see, 13 up, and CF, and then we're going to stop there. Okay, so here's a brute force solution. So this is the brute force. Brute force for I in, let's call this digit letter map. Oh, so our input, interesting. Digits length is going to be 0 to 4. Okay. So 2 digits is n squared, 3 digits is n cubed, 4 digits is n to the 4th. Oh boy, that's going to be slow. Okay, but in this case, with 2 digits, so this is, we're going to get the brute force solution, and we'll think about how we can do better. So for I in digits, there will be as many loops in I as there is length of digits. So in this case, digits is length 2, so we're going to have 2 for loops, for j in digits. String I plus string j. So in this case, this is O of n to the size, where size equals len of digits, time, and space. What is space? Complexity. Let's think about this. Also O of n to the size, time and space. Okay. And size is between 0 and 4. Digits dot length, their size. Okay. So worst case, this is O n to the 4th, time and space. So we have to do better than O of n to the 4th. How can we do better? Let's think about what we were doing here. So we were... How do we do better than O of n to the size? Interesting. O of n to the n? Wait, hold on. So n is the size of the input, right? I'm confusing myself. O of n to the n? Is that right? 2 squared, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's like 2 to the 4. Wait, 2 cubed. interesting. So we've got some kind of a brute force solution, but it probably won't pass all of the test cases. That's okay. The question is, how can we do better? Let's do a few more examples and see if we can get more of an intuition about like where is work being repeated that we could potentially, maybe we can, what can we do? A, D, E, A, let's see, A, D, A, E, A, F, B, D, B, E, B, F. Look at this, D, E, F, D, E, F, D, E, F. So it repeats every single time. D, E, F. So the second value repeats every time. D, E, F, D, E, F, D, E, F. That's interesting. A, B, 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 C, C, C. So like the first time we don't know the order, like we walk through this guy. Okay, so let's do another example. Let's do 2. Okay. Okay, so what are the possibilities here? Just A, B, C? A, B, C. Yeah, okay. Huh, interesting. A, B, C. Okay, let's try, let's do 3. Let's do 1, 2, and 3. 1. So I guess 2, 3, and 4, because 1 is not possible here. Okay, so we're going to look at the solution now. So we got a brute force. We have some idea about a brute force solution. It's going to be O of n to the n. So in this case, 2 raised to the 2, which is 4, but it's not exactly right. Okay, so we have some idea about a brute force solution. We did not come up with a optimal solution. We weren't able to implement either. That's okay. We'll just keep track of what we did and try to do better the next time. Okay, Java solution with a FIFO queue. Interesting. Letter combination without first loop, but some time complexity. Both are single queue. BFS solutions. Oh, breadth first search. Interesting. Wow, that's pretty shocking to me that this is breadth first search. Wow. Okay. So there's, you know, a big part of this problem is just recognizing, oh, I can use breadth first search on this. Wait, backtracking. Wow, funny. The last one we did was also backtracking. He's using breadth first search though. That's interesting. Okay, so let's try and figure out understand his solution. So that means using their code to walk through a solution. Okay. What is going on with this mapping here? Oh, he's using the index 0, 1, 2. The index is 2. It gives the letters in that index. Got it. Okay. All right, so we're going to walk through. Let's walk through 2 and 2, 3 with his code. All right. Okay. Let's do this one first. So we're going to keep track of the variables. So ants is a linked list. So let's say it's linked list. Keeping track of digits. Digits. Goes 2, 3. What else are we keeping track of? We have our mapping. Okay, so this is mapping. I might change the name of the variables. We'll see. We're looping over digits. Okay, so we're going to be going over. So we need to keep track of the index 0, 1, and also I. Okay. Okay, what else are we keeping track of? Where is our... Okay, linked list, got it. Linked list peak, is that looking at the top? Linked list peak. I think it's looking at the top, Java. Retrieves the head, okay. So let's write a note. Peak retrieves the head of linked list. Got it. Okay. What else? Remove. Linked list. What does this do? Okay, so it removes the head. Okay. So it removes and returns the head. Remove and return head of linked list. Okay, cool. What else do we need to know? To care array. So I think it takes ABC and it goes ABC gets turned into ABC. Something like that. An array of characters. Okay, cool. Answer is our linked list. I just like calling this out, so I'm going to do that. Current percentage. You can feel free to change this to whatever works best for you. I'm calling this out. Yes, 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 yes. Okay. Answer out. Okay. Okay. So let's walk through the code. Out starts as empty. If digits is empty, return out. Nope, we're not returning. Let's go like this. Okay. This is where all the action is happening. So we're going to add empty. Interesting. For I, up to the size of digits, basically 0, 1. The size is 2, so we're going, this will equal 0 and 1. Okay, got it. X, we're also keeping track of. X equals character, get numeric value, digits dot char at 2. Get numeric value, okay, 2. X is 2. While out.peak, that length. The question is, what is the length of an empty string? Let's check. I believe it's the same in Python. Let's see here. Okay. Okay, so len of an empty string is 0. Okay. So maybe, so I starts off as 0. Okay, so we're in this while loop. I'll put I'll go like this for like the current line we're at. So we are here. While it equals 0. Okay, now we're here, t. We have another variable to keep track of. T equals out.remove. Okay. For char s, we have another variable to keep track of. Okay. S and mapping of, we're trying to grab, so x in this case is 2. Okay, so this is 2. Let's go like this, 0. Ah. 3, 4, 5, 6, 7, 8, 9. Okay. So now we're here. S mapping 2. For character of S, so we also need to keep track of S. Let's remove this. So S in this case is going to be A. Out. Okay, what? Okay, we're going to add T plus S, which is A. Okay. Now S gets incremented. S is now B. Mapping, okay, so X is 2. S is B. And out, we're going to add T plus S, which is B. What? A, B. Does this make sense? A, B. Okay, interesting. Now S is incremented. And now we add t plus s, which is c. Okay. So now we pop out of this for loop. So we were right here. Now we're popping out of this for loop. We're back up here. We're at this while loop. We're going to peek at out. So in this case, we're at A. Peek is the head. We can keep track of the head as well. Head. Peek is going to show us the head. We're going to get the length of the head, which is 1. But I is still 0, so this will fail. And we're going to go back up here. We're going to increment I. Okay, interesting. Now we're here. Now x is get numeric value, digits char at I, which is 3. Okay. Okay, so while out.peek, so the head is A, the length is 1. Does that equal I? Yes, it does. Length is 1, which equals I. So now we're going to pop into this while loop. So t is equal to out.remove. Remove and return the head. Okay, so A. So now our head has updated to B. T is now A. Now we're going to hop down into this for loop. So we need to update S. So S, we're going to be mapping, we're going to be iterating over mapping 3. Mapping 3. Okay, so now S starts at D. And now we're here. So now we're going to add to out. And so linked list.add. Linked list.add. I believe this is adding to the end, but let's just make sure. Appends the specified element to the end of the list. Okay. Add element to end of list. X add end of list. Okay. Out.add t plus s. T plus s. AD. Uh-oh, what's going on here? So why do we have B and C? Oh, I think we're gonna pop this off the beginning at some point. Interesting. Okay. Now we go up here, increment S, go down here. Is anyone here? No one here. That's okay. All right. S is now E. Out, we're going to add T plus S, which is AE. Okay. Increment S. And then add T plus S, which is AF. Okay. So now we're going to exit this for loop because we've gone through all the characters. We're going to go back up to this while loop. We're going to check out.peek, which is 1. And the length of that is 1. We're going to see if that's equal to I, which is 1. Yes, it is. So we're going to pop here. Now t is equal to out.remove b. T is equal to b. We're going to update the head of our list. T is now equal to b. Now we're going to iterate over mapping 3 again. So we're going back to, so now S is D. We're going to iterate over 3 in our mapping. Iterate over this guy. Okay. So now out, we're going to add T plus S, BD, and then we're going to update S, and we're going to add BE, and then what next? Update S, then add BF. So I'm starting to get a feel. So I'm starting to memorize the algorithm, and I'm able to just do it by looking at this side over here. So I'm starting to at least memorize it. Not fully understanding it, but able to walk through it. Okay. BF. Okay, so we've reached the end. This is not here. Okay, what the hell? Okay, gotcha. All right, so we've reached the end of this. We are right here. We've reached the end. Now we're going to come back up to this while loop. We're going to peek at the head, which is C, check its length, which is 1, check that it's equal to I. It is. Okay, so we're going to now update T. We're going to remove C, set it equal to T, and now we are now here. We're going to iterate over DEF again. Okay. So now we're going to add TS. Oh, we have to update S. I'm going to add CD. CD. Update S. CE. Update S. CF. Okay. So now we're done with this loop here. We're done with this loop here, so we pop back up to this while loop. Now we check out.peak, which is AD, length is 2. Is it equal to I? No. So now we hop back up here. We increment I. I is now 2. And I is, it doesn't pass this test here. So we exit out of this for loop. Now we return out. And is this correct? AD, AE, AF, BD. It is correct. Wow. Okay. And what's the time complexity of this? This is an O to the N loop, where N is the length of digits. This one is O of this is worst case if all of the, so we kept on going through this while loop while there was A, B, and C in out. So in that case there was only 3 values. So wait. Is this O of 1? Out.peak at length equal to I. I goes from the length, goes from 0 to 4. Okay, so worst case, I is 4. Okay, so this is just O of 4, which is a constant, so just O of 1. And then this one is, wow. This is O of, worst case, how big can each of our mapping things be? It can be only 3. O of 3, which is just O of 1. Holy moly. So this is an O of N runtime? Is that right? Wow. That's pretty shocking to me. O of N run time. And space out is, how big is the size of out? A lot of space though. A lot more space. Wait, let's think. Wait, this isn't O of N. There's no way. Well, I wonder that because like this is, so the length of digits is 2, but the length of our out is 1, 2, 3, 4, 5, 6, 7, 8, 9. So like 2 cubed, right? But like this is 2 is a small number. Like if digits is, oh, wait, hold on. We know how big digits can be. Digits is 4. Okay. Okay. Alright, so worst case time complexity, we're getting O of n. Worst case space complexity, we're getting O of n? Did they talk about space and time? Single Q BFS. Interesting. Yeah, so I'm definitely feeling out of practice. This is something that you just got to do a bunch of iterations to get better at it. That's okay. We'll be here every day at 5 during the week. Alright, so I think this is O of n time and space. I'm not sure exactly. I have some intuition about this. Whoops. This tells me I need to like do some more practice with breadth first search. I didn't recognize that this was a breadth first search problem, so I should probably practice like recognizing problems as, solvable by breadth first search. That's all. Thanks for joining us. I will add the link to this solution